Switzerland with respect to wastewater treatment, for instance. We will do the piloting of those technologies before they are implemented in Switzerland. About 20 years ago, or a little more, I came to Airlock, and I was very interested in setting up work on urine source separation. Why did we do that? We did that primarily with respect to the urban water management system, which we wanted to improve. So we wanted to have less nutrients at the treatment plants. We wanted to improve the water pollution control. We wanted, of course, also to close the nutrient loop, but I must say that was not our primary goal at that time, because we were really committed to the urban water cycle. There were some minor things like saving water, increasing flexibility, and also removing micropollutants, and I'm coming back to all this. Why is urine so important for the urban water cycle and wastewater treatment? Well, to most of you sitting here in this room, I guess that this picture is not really a revelation. We have most of the nutrients in wastewater comes from urine, 80% of the nitrogen, about 50% of the phosphorus, depending on how much phosphorus you have in detergents. But I can tell you that when we showed this picture the first time in '95 at an international conference in Singapore, it was a revelation, but most people, of course, found that just a little funny. What is so striking about this is that if we have all the wastewater, we have about 180 liters per person a day. But all those nutrients we have in just 1.5 liters per person a day. So those are concentrated nutrients, and of course we can do something with that. If we look at wastewater treatment, and we look at, we have 100% of the phosphorus, we have 100% of the nitrogen. If we then do simple biological treatment, and with simple biological treatment, I mean actually most of the treatment plants in the US, just removing BOD and not yet having gone to advanced nutrient removal. We see that if we do simple biological treatment, we have some of the phosphorus, or we end up with some of the phosphorus in the sludge and some of the nitrogen in the sludge. But the largest part of phosphorus and nitrogen we have in the effluent, and this is what are causing problems in our aquatic ecosystems, primarily in the coastal areas. Most of you will know those problems about dead zones. I'm also coming back to that. What we saw at that time was, however, that if we take the nitrogen and the phosphorus from urine, if we can remove this part from the wastewater, we will never be able to remove really 100% of the urine. But you see, even if we only remove 80 to 90%, we have hardly any nitrogen more in the effluent. And we have only a little phosphorus, which is relatively easy to remove. So that was the reason, the basic reason that we thought, removing urine from the wastewater, we will be able to revolutionize the whole urban water management system, the whole wastewater treatment of industrialized and non-industrialized countries. If you want to see more of this, we wrote a paper on that in 2007, and what you see here is the typical removal efficiencies of wastewater treatment plants, simple biological treatment, solid retention time 2 days, or sludge age 2 days, 75% of COD, 25% of nitrogen, and a large variety in the phosphorus, because also with simple biological treatment, we can precipitate the phosphorus. We invest a lot of money to have advanced biological nutrient removal, going to a sludge retention time of 12 days, a much larger treatment plant in order to remove those 50 to 75% of the nitrogen. If we do urine separation, or no mix, as we tend to call it at ERWAG, you see we can be as good as advanced biological nutrient removal. But in fact, we can be much better, because if we have simple biological treatment and urine separation, these two numbers are additive, so we can remove nearly all of the nitrogen. In the US, with all your septic tanks, you can also do calculations and see if you put in urine separation, the septic tanks could actually be a rather good solution in many rural areas. Let's look at the status of the wastewater treatment plants when we go beyond the US, when we go beyond developed countries. Let's spend a little time with this nice graph that I took from a recent article in Water Science and Technology. You may know those articles are very short, but actually this is a Dutch group having worked on the nutrient emissions and the nutrient mass balances globally for the last 10 years. So there are plenty of very interesting work behind this, and very much modeling. I cannot go into this. I'll just show you a few pictures from this paper. What you see here is the black. Well, you have all the different areas of the world. Let's concentrate on the developed countries at the moment. In 1970, we had a large part of the developed world with no sewers at all. And then for the rest, about a third with sewers, so no treatment plants. Then we had primary treatment and we had secondary treatment. Secondary treatment is the BOD removal, the simple biological treatment plants. You see, in 1970, we had no advanced nutrient removal. But it came during the next 40 years. It came, but only to our part of the world, only to the developed countries. You see, you have to look really well just to find a little green spot in Russia of advanced nutrient removal in 2010. What we then see is how does that translate into nitrogen emissions to the water courses. We see we have quite a lot of emissions for the developed countries. It went back a little bit due to our wastewater treatment, but at the same time we had population growth. So you see it doesn't translate into much. You see here not a lot of nitrogen, hardly any sewers, so the receiving waters do not get any. They get a lot of nitrogen, especially from here, East Asia and Pacific, but down here, not too alarming. This is our situation today. If we then look, what will happen? A lot of modeling went into this. What will happen until 2050? And what we see here is, well, it's based on modeling and it's based on different prospects for the global situation. A prosperous one, economics goes well, we have people do the right thing with respect to ecology, etc. And then we have the dire one, economic goes down and people do all the wrong things with respect to ecology. We'll see what happens with the situation of the treatment plants. In the developed countries, we will get much better. In the US at the moment, you are building a lot of new advanced nutrient treatment plants, putting in millions and millions of dollars. We also see that in some other countries, if the economy goes up, we'll have some green spots. If we go to sub-Saharan Africa, we'll probably have no nutrient removal even in 2050 and even if the economy improves. But how does it look if we look at the nitrogen? You look at the black ones. This is the situation now. And then you look at South Asia, especially economy goes up and they put in a lot of sewers, we will have a lot of nitrogen in the coastal areas. And that will mean a lot of hypoxia, a lot of dead zones. So you see, we're down here now, relatively small on this graph, and we will, whatever happens, we will go up enormously with our emissions to the watercourses. And this is so important because already now, with the relatively small increases in nitrogen emissions to the water, we see that there's a lot of hypoxic, that's the red dots, and eutrophic coastal areas around the world. When I started showing this map about 10 years ago, there were hardly any red spots down on the in the southern hemisphere. But all natural scientists working on this made the prognosis they will come. And they came. I only have the data from 2010. I think somebody stopped keeping track of this. But there's no doubt that in all these areas where we do not have advanced nutrient removal, where we have these immense amounts of nitrogen to the water courses, we will see more and more of those red dots, which means dead zones. I assume that most of you who have seen dead zones in the US. There's been a lot up here on the East Coast. We've seen them. We've seen the fish dying, everything getting dead. Well, I haven't seen it either, only on pictures, but this is something which is really serious. And you see all the nutrient elimination that we have done in Europe and in the US. These start to get green, which means that the hypoxic zones recover. But we will not have any of this. Well, in Australia we will, but in most of the world we will not have this. So this situation will get really a lot worse. And that's, well, 20 years ago we didn't have those maps, we didn't have those data, but it was obvious to everybody who would work with wastewater treatment plants, advanced nutrient removal will never be able to keep up with the population growth, the urbanization, the sewers who are built all over the world. We will see this picture, and it's quite obvious that will only be worse and worse and worse until 2050, unless we find an alternative to advanced nutrient removal, and that is urine separation. Well, this was a quarter of an hour on the why we are doing this from the perspective of the watercourses. We predicted this 20 years ago, and like a lot of other people too, who were not special in that, we just didn't have the data. But we said we'll do a large urine source separation project at Airmark from 2000 to 2006. We did that. We called it Nova Quartis. There's the word new in that, and the word aquatic ecosystem, because we wanted to show we are not only interested in urine, we are also interested in producing fertilizer. We are also interested in closing the nutrient cycle. But the large global problem, which will be one of the most serious problems of the 21st century, that is how we manage our water in the world. We did then a case study in Durban, South Africa, from 2010 to 2015. I'm not going to talk a lot about that. And we did some urine separation in slums, because at the moment we have 1 billion people in slums, and there are prognoses that before it starts to go the other way, we will have up to 2 billion people in slums without any wastewater treatment. And we think that we should not only bring toilet to those people, we should also make sure that the nutrients from all those people, 2 billion, that's quite a lot, will not end up in the watercourses. So I'm going to talk a little bit about that in the end. You can find, of course, all our homepages with a lot of publications. with a lot of information and also a final report from Nova Quartis. Unfortunately, I don't have it on paper anymore because it was so popular that it went away quite rapidly. And as you see, we started this in 2006, so it's 10 years ago. What did we do at that time? I may be telling some of you a lot of things which you already know, but I know that there are also newcomers to this community, so I'll do it systematically and explain what we were doing in this very large problem. More than 100 people took part of it. The full costs were about $5 million, and we worked for nearly 6 years. What we said was we will organize this project around the nutrient cycle. We will look, do people accept new toilets? Which are those new toilets and can we have them developed? We would look at storage and transport. We would look at the process engineering of urine because we are convinced we have to do urine separation also in the large cities. And we think we have to produce a fertilizer which can be transported from the large cities to the countryside. We will look at the micropollutants, primarily the pharmaceuticals, which are to a large degree excreted in urine. We will look at agriculture. It must sound familiar to many of you working with urine separation today. And then we come back to the people. Do they accept food, vegetables, which have been produced with a urine-based fertilizer? So the first thing we did, literally, was that we put in some Nomics toilets from Sweden, looking nearly like that. And we made a focus group, and we made a lot of surveys and made sure that all the people we were surveying, they had the opportunity to use those toilets. And we were actually quite surprised. 70% of those people 20 years ago found, well, that's a good idea. And I'm talking about conservative Swiss, not progressive people from Vermont. Those who tried the toilets, 80% thought, well, it's not so bad to use a Nomics toilet. And even 86% would accept a Nomics toilet at home. There are problems of daily life. We had people living with those toilets, and the pipes were clogging. You may have experienced that too. It's difficult for children to sit. Even those highly intelligent small children there were not able to sit on this toilet and do what they were supposed to do in the right way. And there was some cleaning and maintenance. Don't be scared. The conscientious mother has taken care that this toilet was disinfected 3 times before the children were touching it. Well, our not so surprising conclusion was those toilets which we had available at that time, they have to be improved. We also wrote a lot on that. We also, after Nova Quartis ended, we went to see what have other people in Europe done. And we got a very nice American headline in American newspapers: Nomics toilets get thumbs up in 7 European countries. We saw actually, wherever we asked, people were on different aspects of those toilets. They were very positive. But we also see that people are not so happy about paying more for such a toilet. You see the mean positive attitude, and then you see different aspects. And this red one is very interesting because the results in this red part, they come from large pilot projects where people were actually living with the existing Nomics toilets for longer, and you see this positive attitude is that they don't want to replace their existing Nomics toilet with a conventional toilet, and you see we are down to about 50% in this project actually really wanting to get a normal toilet again. And you see here it's even worse. So one of the most complicated tasks for urine separation is to produce a urine separating toilet or a no-mix toilet, which appeal to ordinary people who do not really care so much about neither the environment nor their sanitation systems. And we looked in this second work package, we looked especially, well, precipitation clogging is the largest technical problem, but actually we have had, as you will see later, we have had those toilets for quite some time at Ervard, and we found out it's relatively easy to maintain them so that they will not clog. We just clean the urine part with a little bit of citric acid, I think it is, once a week, so you could just have a cleaning agent doing that. But the really problematic part of this is to convince a sanitary company, a toilet producing company, to develop and produce those toilets, because it is actually rather difficult, it's rather expensive to make a whole new type of toilet, and there are no markets, because there will only be a market if we can make large pilot projects, and we cannot do that without decent toilets. So it's a hen and the egg problem. We actually had a company, a German company, making such a toilet, and we were very happy until about a month ago, when I nearly went into depression, because they said, no, we are not going to do that. We're not going to further develop those really nice no-mix toilets, because we don't believe that there is a market for them. So please, Americans, come to our help and produce a nice toilet. Well, as you see, at Ervard, we abolished the mixed toilets 10 years ago. We only have a few of those old-fashioned mixed toilets in our lab buildings. Whatever else we had dual toilets, they produced them for some time. But we realized they were not good enough for pilot projects. People would not accept them. And as a consequence, Rödiger also stopped producing them. We have them all over our institution. Those who have visited us have used them. They function. People are not very happy about them, but they are still not killing me for forcing them to use them. But as I said before, this is really the main problem for getting on. If we could get those toilets, I am pretty sure that we would have a rollout of urine separation in Europe within very few years. The transport is, of course, a problem. You are transporting by truck. We thought we could use the existing sewers at night. We just store the urine in the household, and then at night, when there's no wastewater in the pipes, we would open those storage tanks, and then we would transport all the urine through the pipes. It is only possible in small catchments. We have tested that it can be done. There's a lot of publications on this, also doing peak shaving and a lot of other interesting things using those existing pipes. Whether that will ever happen, I don't know. We thought new urine pipes would be too expensive, and the trucks are not that attractive in the middle of downtown Zurich or downtown Paris or downtown New York. So we said the alternative solution, which we have been working on since then, is that we would do on-site volume reduction, leading to much less transport. If we have very little volume, we could transport the residuals of the urine. We could transport them in the same way or together with the solid waste, which we are already now collecting in the households. So this is what we have been doing in this work package on urine processing. Well, one of the main goals is really the volume reduction, but there are many others. I'll come back to the removal of micropollutants. There are a lot of interesting aspects, biological, chemical, physical processes, and the largest part of research going on is actually about treating urine. Is also very interesting from an academic point of view. You can publish this, etc. We made an overview paper in 2006, and we are just working at the moment on a new overview paper, where we'll see what happened during the last decades. Physical, chemical, you see a lot. I didn't put in membrane processes because until I came here, I was of the opinion that that would not work. Everything I have seen has not been really very successful, but I hear now about the results from Michigan University. So again, thanks to the American coming to our rescue, that actually it can be done, and I think that's very interesting. We started with membrane processes because we thought that was really interesting, but we didn't get very far with them. We were doing some biological treatment, and I'm going to talk about that, specifically nitrification as the stabilization of nitrogen as ammonium nitrate, or as nitrate, so that we would not lose the ammonia in the urine, which has a very high pH. The newest hype is the electrochemical processes. I'm not going to talk about them, but there are different non-biological and biological. It's a very hot topic. It could be interesting because you would be able to make very small on-site reactors, but if it will work, I think it will take about 10 years before they can really come up with something which could be viable. So until now, very few urine treatment methods have escaped the laboratory. What you see here is one of them. Our own one is a nitrification reactor for stabilization of urine, developed within the Luna project. You see here, this is our fertilizer. I have small samples of here. I couldn't take them through customs. The Americans don't like ammonium nitrate. And I didn't want to land in an American prison. But this I dared put in my suitcase, and I brought it, well, officially into the country. It's only a few milliliter. We have a fertilizer allowance from the very, very strict Swiss authorities. Urine as fertilizer is forbidden in Switzerland, of course, because it's not allowed. But this one is allowed, but only for flowers, because there are still micropollutants, there are still pharmaceuticals in them. But we make a lot of this nice flower fertilizer. We sell those bottles for $9 a piece, and they are very attractive to people, so we sell a lot of them. It's 20 times concentrated urine, and the bottles are half a liter, so you can start calculating. We can only sell them at that price because it's for plants in the household. Agricultural fertilizer is much, much cheaper. Here you see we are treating half of the urine from airwalk. This is also now full. This is the nitrification, the biological treatment. Here we have the distillator, which is just a conventional distillator. We are recovering about 96% of the energy, so it's quite good. Yes. The pharmaceuticals. That was something which we really talked about at that time, because pharmaceuticals, micropollutants, was a very hot topic already 20 years ago in Switzerland. And approximately 60 to 70% of the pharmaceuticals which we are excreting, they end up in urine. So our idea was that, hey, if we could just take out the urine, we would have much less micropollutants in the wastewater. We did then do a lot of research with some chemists, and we saw that the risks of the pharmaceuticals and hormones, they are approximately equal from urine and feces, because the really nasty stuff is in feces. But we also saw micropollutants can be removed from urine, so we could at least get rid of half of this ecotoxicological potential. So we think that urine source separation could play a role for abating the micropollutants in wastewater. You may not know it, but the Swiss authorities have just a few years ago decided that in Switzerland we are removing micropollutants from most of the wastewater treatment plants, or the largest one, and we will have to reach that within the next 30 years. And all other European countries are now looking at Switzerland and saying, if the Swiss do it, we may have to do it too. And our ecologists are about to show that that would really help improve aquatic life. We can do it with our favorite particle treatment, just using activated carbon. We remove 98% of the pharmaceuticals, and we expect that when we have done that, we will also get a fertilizer allowance for food, because this has been distilled at 80 degrees Celsius, so there are no bacteria in it, and if we remove all the micropollutants, it's just really a very, very safe fertilizer, much better than what we can buy else. We did some experiments. Not very surprisingly, urine is a good fertilizer, as good as synthetic fertilizer. You have to be careful if you're not treating urine, because pH is high, you can lose ammonia. More surprising, perhaps, Swiss farmers, conventional Swiss farmers, nearly 60% thought, yeah, that would be a good idea to use urine for fertilizer. But they were concerned about hormones and pharmaceuticals, and so are the Swiss authorities. You can discuss the pros and cons, but I'm not going into that. This is what people want, so we can do it for them. We did some evaluation. It was difficult. There are a lot of people here I have heard who are doing life cycle assessments. That's really, really good. We couldn't do it at that time because you also need how much do you invest in the treatment, energy, etc. So it's really good that somebody is doing it now. What we did was very simple. We said, if we do not need the advanced nutrient removal at our treatment plants, but can stay with simple biological treatment, we would have up to $1,000 per household to invest in urine separation. And with some assumptions, and with the assumption that if we could really get this onto the mass markets, produce a lot of toilets, they would not have to be much more expensive than present ones, there would be the possibility to do this as cheap or even cheaper as what we are doing now with nutrient removal. I also did lately some work on energy. I heard this morning that a lot of people were interested, but for time reasons I threw that out. But actually we can, with urine separation, of course, be as good as those who are doing mainstream analogs, for those who are wastewater experts. And if we start to recover the nutrients, the nitrogen, we have the potential to be much better than with respect to energy than what we are doing at the treatment plants today. I talked a little bit, I just have a few minutes, I talk a little bit about what we are doing in slums. We were in the Gates Foundation to come up with solutions for slums. And we said we will try that, but we will only do that with urine separation, because we think that's the only way that we can do a really cheap and environmental friendly wastewater treatment in slums, only looking at toilets. This is the toilet which we designed. I'll come back to this. Storing is their dry toilets, normal urine diverting dry toilets, but with a few extras on it. We would just transport urine and feces like you do here, and we would then treat them at a level of about 1,000 people, because that could be realistic. And we would recover resources, water, nutrient, and energy. Water we would recover. Oh, we could recover that all here. We set up a logistic concept for feces and urine, etc., etc. The principle of the blue diversion toilet is that somebody would come and collect urine and feces twice a week. We have a self-sealing feces container so that that would not be dangerous for the people to collect the feces. We would remove urine by pumping, and we would treat the water on site in a gravity-driven ultrafiltration membrane bioreactor, which we have developed for this project, and we are now doing reverse engineering to bring this back to industrialized, to developed countries, so that in all the countries where we have water scarcity, we would be able to do the same in order to produce a really, really pure water from grey water in households. That's just as an appetizer, if anybody is interested in what we can do outside of the urine separation. So this was it. We continue our story at Water Hub at Nest. Nest is this very interesting new experimental building at our campus. We have the most elaborate source-separated system in there. We have about 5 or 6 different fractions of wastewater, which we are transporting down to the water hub in the cellar. And we are treating urine, we are treating feces, we are treating grey water. And the most interesting thing is that this experimental house, you can find Nest on the net, or you can go to the IWA Conference on Sustainable Solutions in France in October and hear about Nest. And it's open to consortia from all over the world, industry and academia together, who would like to do something new in the building sector. It's not only water, but it's also water, and it's also urine separation, feces treatment, urine treatment, etc. And it's a guest house, so those who will come and visit us in a few years, there may be a possibility to live there. Thank you very much for your attention.
About 45 people online, and I would like to invite all of you online to type in some questions if you have anything that you would like to ask Tove. This is a really special opportunity to have her expertise, and please take advantage of that. Send some questions. If there are people here in the room who have some questions, we will start with those. I have one to start right off, and this is someone is asking, what does the nutrient composition in the urine look like after you use the activated carbon treatment? Is there a substantial loss in the nutrients after you use the carbon treatment?
No, we do not lose any nutrients when you use the carbon treatment. We are treating the urine only after it has been stabilized. So pH is going down to 6.3. So ammonia does not really absorb to carbon at that pH. I'm not quite aware whether we are losing a little bit of phosphorus, but I don't think so. At least it's not a topic at all. We are really losing only the organic matter, and we are losing most of the organic matter. Of course, you have a solution which is clear as water when you have done this.
Someone else is asking, what do you know about the current status of the Gates Foundation project in the slums right now? What has happened?
Yeah. What happens in the slums is that primarily the Gates Foundation wants a toilet where the resources are recovered on site. So not only water as we wanted to do it, but also everything else. We are working on that in another project called Urine Diversion Autocare, where we are stabilizing urine with base, the opposite of what other people are doing with acid. And then we are sort of drying urine, and we are using some more advanced processes for feces, and there are many other working on that. What the Gates Foundation really want to do now is to get those technologies out, out in the wild. So they are supporting all the groups who are working on the RTTC, at least, the Reinvent the Toilet Challenge, they are supporting us for setting up industrial contacts, which is, of course, rather important because no research institute can start to produce those toilets. There is also a lot of other stuff going on which I'm not aware of. I'm only aware of the RTTC, the Reinvent the Toilet Challenge, the more academic branch. But there is, of course, also the Grand Challenge, where the Gates Foundation support a lot of people doing very down-to-earth compost toilets, etc., etc. So, but there you will have to go to the homepage of the Gates Foundation.
Someone here is saying, what do you think it would take for the Swiss officials to be on board with more widespread use of urine-derived fertilizers, given the current uncertainty about the micropollutants?
Oh, that's very easy to answer. They want us to remove the micropollutants, and we can do it. And we will get the, I mean, I don't know whether we have got the fertilizer allowance or whether we'll get it, but that's clearly what the Swiss authorities want at the moment. And I don't think that we can convince them that we can use urine without removing the micropollutants. And of course, they also need to know that there are no risks of microbial contamination. You may know the Swiss authorities are very strict. Use of sewage sludge in agriculture has been forbidden for years. So I don't think that we'll get, in the next 10, 20 years, I don't think we will get any allowances without removing the micropollutants. But I have no crystal ball.
Someone is asking, Honglu is asking, for the micropollutant removal in the urine source, we have tried different AOPs, that's advanced oxidation processes in our lab, rather than the physical removal method in our lab. The major problem that we encountered is scavenging effect from the urine components, such as the ammonium chloride, bicarbonate, and some metabolites. Do you have a comment on that?
I have never worked on AUPs. What was important for us before we used the activated carbon was that we really have removed most of the scavenging organic matter, because else it would be really, really expensive. So I'm sorry, but I cannot. I'm sure there is literature on that, and else I have colleagues who would be able to answer that, and we are always very happy to have questions sent by email. And you can find my email address and also the email address of many of my colleagues on the web pages which I have given here.
Can you talk more about the hen and egg situation with regard to the urine diversion toilet manufacturers and the toilet users? What might be some more entry points to activating this need and lowering the cost?
Yeah. This is, I think, really the topic where we have had the most headaches, because we've tried for 15 years to convince the producers of toilets that we will not have a large market before we have made some larger pilot projects. And we cannot make large pilot projects if they will not produce decent toilets. And they are not that interested in doing that. We have people taking care of the wastewater treatment in Paris, being really interested in doing urine separation in Paris. And we thought that that was enough for this company to be interested, but they still find that the challenges of producing a really, really nice urine separating toilets is too large. And I think that the main problem is that those toilet producers, they have no real incitement to do that, because they are earning good money with normal toilets. So why should they change their strategy? And actually all management theory tells us that it is like that. It's very, very difficult to have a large company change their their strategy so drastically. So it may be that we need new companies to come in, and that's also where I say that perhaps the American can help us. Because in Europe, there's not this very, well, the Americans are much, or the North Americans, I may say, are much more risk-taking when it comes to spin-off, when it comes to new companies. In Europe, we are much too afraid of failing. And I think that you have here a much more vibrant atmosphere with respect to new companies. And it may be that we need new companies to make those toilets with some money for taking the risk. But I must say that I hope that some of you will have some really good ideas, because, well, it's not really my main competence. I'm a conventional wastewater engineer, and I know about nitrification and things like that, but I've never really studied how to get companies to produce anything. I hope we'll have some really interesting conversations during those 2 days here.
We'd also like to ask you, have your colleagues at AVOG adopted urine source separation in their homes? And why or why not?
Yeah, no, we are not really doing things like that. I have no mixed toilet at home because I don't see why I should have it. It's we are working very academically in this. We have no mixed toilets at our institute, only no mixed toilets, and we have that because we think this gives a really powerful signal towards the outside. But there's not, in Switzerland, there's not this idea of, may I say, grassroots coming up with toilets in their own homes, etc. So I think that there are different cultures, and the culture in Switzerland is not inviting that. In Sweden, it was totally different. I'm going to talk a little bit about that at the dinner tonight, because I think it is an interesting cultural difference, and I'm very happy that this cultural difference exists and that you are doing things differently here.
Mm-hmm. And could you speak a little bit more about the urine collection system in the Nest building? What is the cost premium compared to a conventional sewer collection plumbing system?
Yeah, I don't have the data here on that, because it's so difficult to calculate those things. In the Nest building, it's clearly experimental, so it has been really expensive. But we have had sponsors from industry paying those pipes. That's also why we are not really aware how much they cost, because they just gave them to us. In the AVOG building, we had just urine separation, and that was not really expensive. We were talking about, I mean, in a new experimental setup, I think $40,000 extra expenses for all the piping. In a new building of this size, that's nothing. It costed millions to make the building. So as soon as you are setting up new buildings, this plumbing is not really too expensive. In old buildings, it's different.
Do you have some examples of successful advocacy for code change for permitting UD systems in Europe, with or without micronutrient removal?
For the fertilizer, you mean?
Yeah, for code changing.
Yeah, in Sweden, they can use urine on agriculture and everybody accepts it. That's a very, there was no discussion of that. The Swedish people, they prefer urine fertilizer to synthetic fertilizers. Carl may be able to explain us afterwards why this is. Else, I must say that it has been really tough in Europe. There are not so many countries working on this. There's Sweden, there's Switzerland, there's Germany, a little bit Denmark, but really very little. Holland, I think the Dutch are doing some very interesting stuff, but I'm not sure that they are still doing that they are already doing fertilizing. So I think that, again, that's room for the American.
Someone is asking, what about our other allies? Are the oceanographers, the limnologists, other people who are tracking the algal blooms, the eutrophication in dead zones? Where are our allies among other scientists in the world?
That's a really
in other fields.
Yeah, I think that's a really interesting question, which really started to occur to me this month or two ago when Duravit stopped their toilet production. Because I realized that we may have been too narrow. We don't have this advocacy from the natural scientists. We're just using their data. When we have talked to them, they have not really been interested. We're trying to set up, or our director is trying to set up a synthesis center at ERVAC, and I think that the whole nitrogen discussion could be really such a topic where we could draw in these very, very knowledgeable people on nitrogen and combine and discuss with them whether we could make some common advocacy. I think that is a very brilliant remark.
Mm-hmm. And it's somewhat related, but can you talk a little bit about agricultural allies at AVOG or other people who in the agricultural sector who are involved or interested?
Okay. We always had some support from the agricultural authorities, but again, without micropollutants in urine, I think they're just not so interested. What was very interesting is that in Denmark, shortly, the trade organization for the farmers, they set up some beer cycling at the largest festival in Denmark, the Roskilde Festival. The young ones among you should come to the Roskilde Festival because it's really fun. And there they collected about 50 cubic meter of urine, and then they fertilized a field where they grew barley for producing a pilsner. And that was set up by the trade organization for agriculture in Denmark, who really wanted to make a point that we should go towards a recycling economy, not only internal on the farms, but also include people. And well, I'm normally in Denmark in January for teaching, and I'm going to see them and try to hear whether they mean that seriously or whether it's just PR. And I also think that, well, farmers in Denmark, they are very pressed for reducing the nitrogen emissions to the watercourses. And they may have to take out quite a bit of agricultural land in order to protect the watercourses. And it could be possible that they would see, hey, if the people in the cities, if they get much better on reducing their nitrogen emissions, for instance, through urine separation, then agriculture could emit a little more. So I think that this, again, is a brilliant question, and I think there's very much potential of this. But we haven't done it till now. There are many things which we haven't done.
Great. So there are a few more questions, but I think we'll end it. And those of you who have questions from here, you can ask Tove at a later time. I want to thank all of the folks who've joined us on the webinar for participating today, and please feel free to email us at the Rich Earth Institute. Some of you may be future participants, and we will let you know when we have another gathering of this type. We're very grateful for your time with us, Tove. Thank you so much. So we're going to sign off on the webinar.